In honor of National Nutrition Month, join us as we speak with experts to share their insights, tips, and strategies to help you make informed food choices and maintain a healthy lifestyle. Throughout this month, we'll cover topics such as how to avoid a vitamin B12 deficiency in plant based diets, the impact of genetics on your nutrition, and much, much more. Stay with us. In today's episode, we are speaking with Dr. Billy Hammond about carotenoids, what they are, their health benefits, and how consuming carotenoids can help combat age related diseases. Stay tuned. Dr. Billy Hammond is a professor in the Brain and Behavioral Sciences program at the University of Georgia. His research is on the role of diet and lifestyle in the development of neurodegenerative disease. Welcome, Dr. Hammond.
Thank you for having me.
Absolutely. Dr. Hammond, this is a very interesting space that you operate in. Your research interests primarily really focus on the human visual system, but your professional activities also span the field of food and nutrition. Can you tell us how you became interested in these two areas and how they intersect in your work?
Yeah, so my training is in neuroscience, but anyone who studies biology long enough learns that all these systems that you study, the nervous system and the immune system and the digestive system, are actually very interconnected. I mean, we sort of learn them as if they're autonomous for pedagogy reasons, but in fact, they're so interrelated and interconnected, it's hard to know where one begins and another ends. And so, for example, the nervous system connects with the immune system. That's why when you're stressed, you often get sick. And you can look at lymph nodes, axillary lymph nodes, for example, and they're filled with neurons. The digestive system has like 100 million neurons. It's the enteric nervous system. So the two are very, very interconnected. So your brain and your visual system is very, it's composed of the elements of your diet. So it's a very natural segue. I mean, most of the neurotransmitters that your brain uses begin in your gut. So the intersection between the two disciplines was very obvious, and I started studying its role very early.
Thank you for sharing that. This is very insightful of how our body is sort of connected in that way. You did a study in 2022 that explored how dietary behaviors can play a significant role in preventing age-related diseases in women, particularly through the intake of pigmented carotenoids. Can you start off by explaining to our listeners what carotenoids are?
Yeah, sure. So just in the, sort of in the larger context of how nutrition affects the brain, I mean, first of all, if you think of the brain is like 60% fat. And so its
Mhm.
composition is influenced by the fat in your diet. So for example, fat can be butter, which is a solid, or olive oil, which is a liquid. So depending on the kind of fat that's more prevalent in your diet, it changes the actual composition of your brain and how it functions, how it ages. There's there are reasons why vigorous exercise has such obvious effects on your mental state and your brain health, and the probability whether you'll suffer depression, etc. Because the brain is very vascularized. If I run around this building a few times and I'm out of breath, all that oxygen goes right up to my brain and affects the biochemistry of my brain and how it functions. So I started studying carotenoids because carotenoids appear to have a particularly important function in the retina, which is like a little slice of brain, and the brain. And what they are is they're sort of these pigments that are in green leafy vegetables and colored fruits. And they, there's hundreds in the natural world. The body absorbs about, 20 or 30 or so. and they're different types that go into different tissues. So, for example, lycopene is the carotenoid that makes tomatoes red, and it goes into the prostate gland of men, helps prevent prostate cancer. Beta carotene is the carotenoid in carrots that make them orange. That goes into the corpus luteum of women, for example. So these very specific carotenoids go into very specific tissues and have very specific functions. And so the two carotenoids that seem to be particularly important for the retina and the brain are lutein and zeaxanthin. And they're related to the probability of a major eye disease called macular degeneration, and the development of degenerative processes in the brain. So a lot of current studies, ours and our lab included, look at the role of those pigments in preventing loss in brain function over time. And they're very heavily concentrated in very specific important regions of the brain. So, for example, there's a lot of lutein and zeaxanthin in the hippocampus, and that's an area of the brain that's responsible for encoding memories. So it has a lot of function and information processing. So that was the basis of that, and why we started looking at women early on is that women, there's an old clinical rule called the mortality morbidity paradox, and basically the rule was that the diseases that kill you more, men tend to get, and the diseases that make you sick, or morbidity, women tend to get more. So women may live longer, but they suffer more of these age-related conditions like osteoporosis, and the 2/3 of the people that have macular degeneration are women, or 2/3 of the sufferers of neurodegenerative diseases like Alzheimer's disease are women, or they have higher rates of just a variety of these kind of conditions, cataracts, and even if you sort of correct for the difference in life expectancy, women tend to have a higher prevalence of these conditions.
The obvious question to me then becomes, why women?
Why? Yeah. So it's a great question, and sometimes these things can be related to genetic differences. So, for example, a lot of sex-linked traits are based on the fact that men lack that little extra arm of their chromosome. So if I have a color blindness problem and I'm a woman, then I have a redundant gene that can take over because it's on that extra arm of the chromosome. But men don't have that. Hence, color blindness is much higher in men than in women. But a lot of these conditions relate to, as far as neurodegenerative diseases, relate to other aspects of biology. So if you take the case of carotenoids, women tend to have a little bit higher on average. These are all average effects, of course. Higher body fat percentage than men do. And these carotenoids are also stored in body fat. And there's a reason why that. Women, because they have children, have to have more sort of reserves to handle the time during childbirth. So they will store a lot of these things in fat and of course they do a lot better in a famine, and they have things available for a developing baby, but it draws from their own stores sometimes. So it means that women, if you just, all things equal, if you measure the amount of these carotenoids in the retina of a woman, they tend to be less on average than the retina of a man because of that distribution of resources, basically.
Interesting. And going back to your 2022 study, you mentioned, so you talked about some of the carotenoids. Help us understand all these different types that exist a little bit more. And then is there a hierarchy of importance here? Like, these are the ones you should worry about versus these not so much.
Yeah, it's interesting. So one thing about diet, people that study diet, is that they it is very much a trait to talk about various components of food in isolation. And especially in the Western model of medicine, we have a real pill for every ill kind of model of thinking about, and one thing, in fact, that's made dietary and nutritional science more compelling to the American public is when you can sort of isolate a thing and then relate it to another thing. So if I can say, oh, lutein and zeaxanthin go into the central area of the retina and they prevent macular degeneration vis-a-vis these mechanisms, then people find that kind of logic very compelling. But if I just say, a very healthy diet is good for you, then it's sort of amorphous and it's just hard. It doesn't have that sort of Western science compelling feel to it. So, the first point is that food, as we evolved in nature, food like ourselves, food usually isn't isolated. So if you take vitamin E in a supplement, what it is alpha tocopherol, a synthetic form of alpha tocopherol. If you get vitamin E in food like an almond or something, it's alpha, beta, gamma, delta, all these various forms of tocopherol and tocotrienols. And all those various forms of the chemical go in different tissues and do different things and interact in complex ways. If you take it just as a supplement, then you get one, and that goes into one. It's a very different kind of thing. So food, like ourselves, sort of evolved over millions of years to have this kind of complexity. And not to be all Gia, we are all one with nature about it, but we evolved together with nature. We are more microorganism than human. And so what we've done is sort of make a parking lot out of our biology and sort of separated ourselves from the natural world, but we are very linked to it. So in the very beginning of life on this planet, life was competing very strongly against each other. So plants started making oxygen to kill other plants, and to exist in these scarce resources. So then those plants started making antioxidants to protect themselves from the oxygen, which was basically poison. Oxygen is a really combustible gas that explodes and rusts metals, but these plants made antioxidants to protect themselves from the oxygen, and we sort of piggybacked on that evolution, So for example, we have this very oxygenated brain with all that fat, and you think about what oxygen does to fat. It spoils fat. So if you have chips and you leave the bag open, they get stale because oxygen oxidizes the fat in the chip. Or if you leave a piece of fish out overnight, it goes rancid very quickly because of the oxygen. So if you look at a nice wild piece of salmon, it's very pink because the salmon has concentrated lots of carotenoids in its flesh to protect it from all that oxygen. Omega fatty acids are very good fats. They're very fluid, and the brain is all about information transfer. So you don't want like rigid fats, like saturated fats. But omega fatty acids are super oxidizable, and you have a really oxygen-rich environment. So what we did is we evolved to use this very old defense of plants to help us have all this fat and thrive in this very oxygen-rich environment. This is why when babies are born in premature in respiratory distress, they will sometimes develop that eye disease, retinopathy of prematurity. You have to really be careful and titrate the oxygen in the incubator because they're put in these oxygenated incubators, and that's why they go blind. It's like Stevie Wonder had this. His blindness was from this form of eye disease.
That's interesting. And so essentially, there are these. To come back to the different forms of carotenoids, are there certain forms that we should look at or be aware of, at least in our diet?
Yeah. So the big ones, right, are beta carotene. That's the one that's in carrot juice. Once I was giving my kids lots and lots and lots of carrot juice, and they started turning orange because it goes in your skin and causes carotenemia, and that's not harmful really, but it's it go and it's good, very good for your skin. There's studies that show that carotenoids increase the the sort of hydrophilic and lipophilic nature of your skin and the elasticity of your skin, so they're healthy for skin. But beta carotene, lycopene in tomatoes, astaxanthin is a very good antioxidant that's been related to dry eye disease. Lutein and zeaxanthin go into the macula of the retina and into all these pivotal areas of the brain. Those are some of the big ones. And then, like I said, they're very common in colored fruits and green leafy vegetables. That's one of the reasons why green leafy vegetables are so healthy.
And I like how you're talking about even the different colors. So I think of the carrot and the color of the carrot, or the green leafy vegetables, like you said. So really, when a dietitian or someone mentions to eat the rainbow, there is a lot behind eating the rainbow, is to get this different variety of different carotenoids as well.
Yeah, that's right. So carotenoids are the pigments, so they give the colors to a lot of these different foods. And there's also other flavonoids, like in red wine and grapes, are colored, and they're also very healthy for various reasons.
That's interesting. You've also done extensive studies on the effects of lutein. You just mentioned that, as well as zeaxanthin, on aging health. Could you expand on the significant findings from your studies and their impact on health, especially as one ages?
Yeah. So in terms of what causes age-related change, I mean, one way to think of it is your skin. Surface tissues that encounter a lot of sunlight. Is that oxygen is in the atmosphere is normally inert, but when it encounters some energy process like light, it can become reactive, and so that's what's called oxidative damage. So a lot of what damages skin and really oxygenated tissues, like your retina, is the most metabolically active tissue in the body, and so it uses tons of oxygen and blood, and so of course, light is focused on the back of your retina your whole life. So the cornea and the lens in the front of your eye is constantly focusing an energy source to one spot in the back. So you can imagine, if you have a lens and sunlight and you focus it on one little spot, that's what causes a fire, because it concentrates the energy in that one spot. So what will happen with a lot of people is that they'll get a hole in the center of their vision. That's what macular degeneration is. And so lutein and zeaxanthin are yellow filters. They're like internal sunglasses. And what they'll do is they'll filter out some of the more actinic portions of that light, and the parts that actually turn oxygen into reactive oxygen. So they protect the retina from photooxidation, is what it's called. So that's what they do in the eye, and that's how they prevent that specific illness in the eye. And like I said, in the brain, they have a couple of functions. One is to prevent, inflammation, and chronic inflammation is another big promoter of long-term aging. So they're an anti-inflammatory, and they're antioxidants, and the brain has a ton of antioxidant stress, So they do those two things, but they also probably affect how neurons function. So one reason the brain has so much fat is neural tracts are covered in fat. And the reason they're covered in fat is that makes the neural conduction very fast. So people who have demyelinating diseases like multiple sclerosis, for example, one of the very early symptoms is called optic neuritis. They get inflammation of their optic nerve. And so the reason is because their myelin is it's fat, basically, and when you're affecting the myelin, that's what causes the inflammation. And the reason your optic nerve is so myelinated is vision needs to be super fast. If something is going toward my face, I have to process it extremely fast. You think of like baseball players, and we did a study of baseball players and showed that we could make it even faster for them. But if you're throwing a ball 100 miles an hour, 67 feet, a batter has to hit the ball within a few hundred milliseconds. And that's literally faster than you can see something. So it takes 500 milliseconds to consciously perceive something. So they have to actually hit the ball faster than they can see it. And the fact that they can do that as often as they can, a good batting average is like, four times out of 10, say. But, that's pretty good. And I've tried this myself, and, it's like, it's past me before I even knew they threw it. It goes so fast. But the point is, vision has to be really fast. They have all this myelin and these carotenoids protecting it. And so what it does, in effect, is increase the overall efficiency of the system. It makes processing quicker. And if you think about processing, it's a real cognitive fundamental. When you're remembering things or verbal fluency, all these things require fast calculative speed. And that's one thing that really declines with age. Older people may become wiser, but they also become slower. If they're working on a spreadsheet or something, you're just like, let me do it. Because you slow with age. And that's one of the reasons. So one of the big areas that we study is how carotenoids, affect those cognitive fundamentals of brain function. And it extends to lots of things. Like another aging test is the standing balance test. So you have people stand on one leg, shut their eyes, and just see how long they can balance. And that's improved with carotenoid intake. So diversity of functions.
That is so interesting. You don't realize that all that is related to a lot of what you're intaking in the foods that you consume.
Yeah, I mean, I think this old adage that you are what you eat is in some ways quite really true. We are, and people forget, I think, the importance of just physical structure in aging. So when I back in the day, all medical schools were allopathic schools. They didn't teach anything about nutrition. They were all treat disease. But there's a new movement of osteopathic schools. And osteopathic schools come from the old tradition of osteopathic medicine, which is basically the idea that, your skeleton and your muscular system is the foundation of health. It's structural. And as people age, one of the better and more healthy things to do is to work on your structure. This is particularly true of women, by the way. They really benefit from weightlifting and heavy exercise because it improves their structure. We have this spine of bone and your spinal cord that goes in the center of it, and that's a pretty precarious arrangement. Our physical structure is precarious. I mean, it has some advantages, but being bipedal has some real disadvantages too. And a lot about modern life is not well designed for how we evolved. Take the fact that we're myopic. Like about half of Americans now wear glasses, and in some Southeast Asian countries, it's almost the entire population. But think from a Darwinian perspective how bizarre that is. Imagine another animal that was unable to see. You wouldn't evolve in the wild very long if you couldn't see to find food or avoid predators. So there's tons of conditions like that for humans that have resulted from modern life. Our kids now have as their sort of developmental signal devices. So when a small child is watching TV and looking at devices all day, that's a very different environmental input than what we had for most of human history, all integral to that. So we evolved in collaboration with all the rest of nature. And so, what you put into your body is makes your body. If I have
Mhm.
a car, I wouldn't put really bad gas in my car and then expect my car to run well. And we are
Mhm.
people just in just the same way. Even down
Mhm.
to things like how we think and our personality and our psychological states. Those are created by the physical structure of your brain, which itself is a result of how you eat and how much you exercise, how you take care of your cardiovascular system, how you sleep. One of the one of the funny things is just how important sleep is. People are like, oh, it's
Mm.
sort of surprised that sleep can have so much an effect on your brain. But there's a system called the glymphatic system. So when you sleep, your brain actually shrinks by as much as 20%. And then
Oh.
all the lymphatic fluid in your brain swishes around like a washing machine and clears debris. And so if that doesn't happen, all that debris collects over time. And debris is the killer of tissue, right? You want to look at real young baby skin, it's clear and beautiful. But older skin, you see the debris. You look at an
Mm.
old brain, it has debris. So
Mm.
so not accumulating that debris is one of the great effects of good sleep.
Mhm. Oh my, how interesting. And speaking of which, Dr. Hammond, you mentioned that there's a strong parallel between the central nervous system diseases and carotenoid intake. Can you elaborate a little bit more on this relationship and how do carotenoids really help fight against associated diseases?
Yeah, sure. So one of the sort of more obvious and clear examples is lutein and zeaxanthin. That's a lot of our studies. And so what happens when you have, say, a green leafy salad for lunch? A lot of spinach in it, say. So you have these carotenoids, they're fat solubles. They go into your digestive system. They're bound by lipid proteins, and then they're delivered to the very center of your retina. Those two, lutein and zeaxanthin. There's that area of your central retina is called your macula, and they concentrate there in really high amounts. And when I say high amounts, I mean they can be almost as dense as my eyelid. They're dense, and so they concentrate right in the area affected by this disease, and they're antioxidants and blue light filters, so they prevent the effects of light damage on that area over time. You know, it's sort of like it's weird to think that the thing that gives us light, is also the thing that ages us. If you ever look at people who have very nice skin over time, they're either out of the sun or they just have a lot of pigments protecting their skin. So very pale individuals who get a lot of sunlight have much more aged skin than not. So so pigments can absorb out that damaging sun, and of course that's why we evolved to have pigments. The closer you evolve to the equator, in terms of time back from your ancestry, the more pigment you concentrate in surface tissues, like your iris and your skin. But carotenoids are
Mhm.
pigments as well that go into neural tissue and prevent that damage.
This has been such an it's been such an interesting way. I almost feel like we can keep going here, Dr. Hammond. I do have one quick question for you before we wrap up. Are there any health consequences for consuming too many foods high in carotenoids?
Yeah. So again, great question. So the short answer is no. I mean I think that especially foods, like I said, have this natural array. The worst thing that could happen is that you get a little carotenemia. You can always tell the
Mhm,
difference
mhm,
between carotenemia and like jaundice because jaundice affects your sclera, the white of your eye. This carotenemia affects your skin. But what happens if you quit having so much carotenoid is your skin will just lose that color. and and there's nothing harmful about it. It just goes into your skin. Sometimes what has happened is that people will take doses, very, very high doses of certain carotenoids, and that's taking it. That's not as natural as just getting it in your food. And even then, the consequences are minimal. But it's always the best bet if you just get things like that from your food.
Okay. With that, Dr. Hammond, thank you so much again for making the time. I want to thank you for for being on here. How can our listeners just connect with you and learn more about your work?
Sure. Well, I'm a professor at the University of Georgia, and my name. I have a web page with my email on it, and please feel free to email me anytime.
Great. Thank you so much, Dr. Hammond. And to our listeners, share with us some of your favorite carotenoid rich foods that you've incorporated into your diet and how they've changed your health, perhaps. Again, head over to our Facebook, head over to our Instagram at Yumlish, find us there. Find this podcast post and comment below for this question, which is again, just sharing with us some of your favorite carotenoid rich foods that you've incorporated into your diet and how they've changed your health. And with that, Dr. Hammond, thank you so much again for your time.
You bet. Thank you.